Hey everyone, I am back solving Advent of Code 2025 day 11 today. So we're second last day already. It's gone by really quickly. But let's see. So the puzzle input is this. Let me paste it in. Cool. Okay, so let's see what the question is saying. So this is a server rack. The device followed by the list of devices to which the output is connected, which means B has two outputs, one leading to D and one leading to E. Issue isn't a specific device, rather flowing from a certain path. Data only flows from a device through its outputs, it cannot flow backwards. Okay. Focus on the device starting with the one next to you, which is U, and then out. Every path from U to out, take a connection from U to BB. I see. So this is essentially a DFS on this solution here. So the outputs, I guess we can literally just parse it as the graph already. Let's split by the input outputs raw, right? And then we have the outputs raw split by a space. Let's print out the input and the outputs. Day 11, part 1. Let's test this. I misspelled anything? I did not. Okay, let's just make sure that we did not print the right text. Hold on. Day 11 should have triggered. Is this the right day 11? Oh no, this is 2024. My bad. No, day 11.txt. Yeah, my bad. Cool. So yeah, so we have the appropriate inputs, we have the appropriate outputs, and we want to build the graph basically. So let's just say this is a default collections, import the default dictionary. It's a default dictionary of the lists. I guess a list doesn't really matter in this instance, but let's just say it's a list. We can say that the graph at a given input appends the outputs, or I guess is equal to the outputs. I'm assuming we don't repeat the keys, so that's fine. And then we can just return the graph. So here, there should be a dictionary of string with a list of strings, and then we can print out the data. Maybe let me increase the font size so you can see better a bit. Yeah, so you can see AA starts with U and this. So then we're interested in all of the paths. So let me just call this paths instead. Paths, we can call this the node, which is the current node that this belongs to. The node is going to be a string, and we're going to return an int. So so one thing we can do is you will notice that it can do a sort of roundabout path where it goes to U to BB, BB to DD, and so you will basically want to try all of the paths. My suspicion here is that there isn't any form of cyclic paths, so I think that should be the assumption we make. So as going with that assumption, we would say for every output in the data at the given node, right? If the node happens to be equals to U, we can return 1 because that's the paths. P equals to 0, and we can say P can increment by the paths given this output, and we can return P, right? And then we essentially want to say for return paths where the start is U. Sorry, so the node has to be out. Yeah, so in this case here, it says it takes 5. So yeah, today this was relatively straightforward as the first part. So that is the first. Second was 508. Cool. For the second bit, we say that now along the problematic path passes through DAC and FFT. So you need to find from the server rec out. You also need to find all visit DAC and FFT in any order. Yeah, so instead of U, we start with SVR, and then we look at the paths, and then we want to check which of the paths actually visit both of them. Yeah, so it's a slightly modified version of this DFS. So let me just print this, and the change here is that we are actually looking at SVR. So maybe let me just change the input to fit this. I'm thinking of making my utility a bit more powerful by letting me pass an input file. For now, we just kind of hardcode which input file we read from, but that might need to change. Okay, but the point is, let's try part 2 with the test. You can see here that it takes 8 because there is 8 possible paths, but we only want to take 2. So as part of the traversal of my path, we can either keep track of the total path that we have seen and just check if the 2 are found. That is one possibility, so we can kind of see the path, which is a set of strings. If we can check if FFT is in the path and DAC is in the path, we can return 1, otherwise we can return 0. And what we want to do is we want to say that the path would have visited the current node, so we can add to the path. And we can say that this is an empty path for now. Yeah, so in this case here, you see that it returns 6, but that should not be the case. So let me just print out the path, just to be sure. So yeah, so you can kind of see here that the path started with, let me just move this to one side. You can see here, the very first path is AA to FFF to SVR, but that should not be the case. Yeah, so SVR goes to AAA, AAA goes to FFT. Okay. Ooh, that's strange. Let's see okay. I'm not entirely sure why it's doing this. Oh, because it's not a list. So it visited some set of these paths, right? Yeah. Yeah. The alternative here is we could do, and so instead of tracking the entire path, we can say DAC, which is a boolean, and FFT, which is also a boolean. So we can return int of DAC and FFT, and instead of tracking the path, we say that if the output is equals to the DAC, or if the output is equals to DAC, we want to set this to be true. Else if the output is FFT, this is DAC and FFT. And then before that, we did not visit either paths, so we would do this. Let's see. Oops, this should be FFT should be set to true. Yeah, so in this case it returns 2. So we can actually just say that DAC P, I don't know what's the good name for this, DAC or DAC. We can say FFTP is the output is equals to FFT, or we take FFT and then we just pass in DACP, FFTP, right? Cool, and then if we just run this against the new algorithm, I suspect now it creates much more complex paths that could potentially have revisited certain states. So maybe let me, from the functools, let's import cache maybe. And then we can do maybe a cache. Yeah. This might be wrong. I'm assuming it is actually wrong because I don't think it would have been this easy, but let me submit. Oh, it was actually this straightforward. Cool. So essentially what we wanted to do is, this is a super simple problem today, where the first part really is just comprised of, maybe let me just add the solution. Let's discard this one. Solve day 11, 2025. But essentially the problem here is we are given the inputs and outputs. We treat this as a graph. So the inputs on the left is the node, the outputs is on array. We assume the keys don't repeat, which is actually the case. Afterwards, for the very first part, we just wanted to perform a DFS from U to out. And I think in this particular instance, we are guaranteed that there is no repeated paths. So we can kind of always ensure that we find the path. So the DFS is super simple. We just check if the current node is out. So we return 1. We just accumulate the number of paths that reach out. And we start with U. The second part is slightly more complicated, where we actually want to make sure that a path passes through two different nodes. So the way we do it is we have a very similar logic in DFS, but besides just the node, we also keep track of two variables, the DAC and the FFT. The DAC tells me if the DAC has been passed, FFT tells me if the FFT has been passed, and so when we reach an out, we just return whether or not DAC and FFT have been passed. And the way we solve for this is, for each time we iterate through all of the possible outputs, we just do either, the output is either DAC or FFT, or it's the existing value, and we do an OR because if it is true, we want to keep it as true. If it is false, but we now see it's true, it becomes true, and we just pass this in. The problem here is that we could potentially visit a lot of repeated states. So by adding caching, we simply simplify the searching by a lot because we can memorize the values we have seen before. But cool, yeah, this was pretty straightforward. It was one of the very first days I finished below 15 minutes. But thank you guys for watching. I will see you for the last day of Advent of Code tomorrow.